Hello, my name is Henry Soler. Today, I come to talk about the resistance of materials. Material resistance. It is called in many cases mechanics of materials. It deals with the behavior of solids, objects subject to the stress and tension. The subject refers to various methods for calculating stresses and strains in structures. Methods used to predict the response of a structure under load. Definition. Resistance of materials deals with the force and deformation that result from their action on a material. The stresses and strains that develop within a mechanical member must be calculated to assess the load capacity of that member. The applied loads can be axial or rotational. Material strength refers to the point on the stress-strain curve. There are several types of calc. Transverse load, which are the force applied perpendicular to the longitudinal axis of a member. Axial load. In the applied force are calling with the longitudinal axis of the member. The force causes the member to stretch or shorten. Torsional load. Torsion caused by a pair of equal elements and oppositely directed pairs of force acting in parallel planes or by a single external torque applied to the member having a fixed and against rotation. Stress terms. Sigma is equal to F divided by A, where F is the force action on area A. The area can be the uniform area or the deformed area. Uniaxial stress is expressed by compressive stress is a state of tension that causes compression in the material. Tensile stress is the stress caused by pulling the material. Shear stress is the stress caused by the faces of the material sealing past each other. Stress parameters for resistance. The stress of the material can be expressed in various parameters of mechanical stress. These are cyclical quantities while harmonious dimension at pressures and force per unit area. The traditional unit of measure for force is MPa and PSI. The elastic limit is the lowest stress that produces a deformation. Compressive strength is a compressive stress limit state that leads to the failure in a material in the form of ductile failure or brittle failure. Tensile strength is a limited state of the tensile stress that leads to tensile. Fatigue strength is a more complex measuring of the strength of a material that considers several loads, even in an object's service life. Impact resistance is the ability of the material to withstand and suddenly applied load expressed in the terms of energy. Strain parameters for resistance. Material deformation is the change in geometry created when stress is applied. Strain is a mathematical term that expresses the trend of the strain change between the material field. Deflection is a term to describe the amount to which a structural member is displaced when subject to an applied load. Stress-strain relation. Elasticity is the ability of material to return to its previous shape after the strain is relaxed. The modulus of elasticity can be used to determine the stress-strain relationship in the linear elastic portion of the strain-strain curve. Plasticity or plastic deformation is the opposite of elastic deformation and is defined as irrecoverable stress. The same terms. Maximum strain is the maximum stress that a material can withstand before breaking or wearing. In imperial units, the unit of effort is expressed as pound force per square inch. A factor of safety is the design criterion that an engineering component or structure must achieve. Fs equal UTS R, where Fs the factory factor, the safety factor, R the applied stress, and UTS latch stress. The margin of safety is also sometimes used as design criterion. MS equal load failure safety factor for prediction load. Test allowable stress are also known as design stress. Design stress that have been determined from the ultimate values or the yield points of the materials. The failures are called fatigue failures, theories of failure. There are failures theory. Maximum shear stress theory. The theory postulates that failure will occur if the magnitude of the maximum shear stress in the part exceeds the shear strength of the material, determined from uniaxial test. Maximum normal stress theory. This theory postulates that failure will occur if the maximal normal stress in the parts exceeds the maximum tensile strength for the material as determined from uniaxial test. Maximum strain theory. This theory postulates that failure will occur when the strain energy per unit volume due to applied stress in a part is equal to the strain energy per unit volume of the yield point in uniaxial test. Maximum distortion energy theory postulates that failure will occur when distortion, the energy per unit volume due to applied stress in a part is equal to the distortion energy per unit volume at the yield point uniaxial test. The mechanics of fracture was established by Alan Arnold Griffin and George Rankin Irwin. This important theory is also known as a numerical conversion of material toughness in the cause of crack. Takeo Yokobori proposed fracture because each fracture law, including Krebs failure criterion, must be combined non-linearly.